everyone, we are finally here at the last of 23.2 part 5 today, and we're going to finish up talking about the half-angle identities. So in the last lesson, we spent some time deriving the half-angle identities for sine, cosine, and tangent, and important that you have these written down as we continue to work with them today. Now, today's portion is again going to kind of focus on using some angles on triangles and substituting them in. So what we see here is that with the sine examples and, or this example and example E, they're giving us the sine of an angle and they're telling us that it's negative. So we know it's either going to be quadrant 3 or quadrant 4, but because they're also telling us the cosine is less than 0, so negative, it has to be quadrant 3 as opposed to 4 because cosine would have been greater than 0 there. So it's going to give you some identifying information. And we're looking to find the cosine of theta divided by 2 and use the double angle formula. So for the half angle, I mean, the process is the same as what we've been talking about. You want to draw that reference triangle, plug in your x, your y, your r value, all that fun stuff, and then identify the fact that when we use the cosine, it's going to be negative since this is a quadrant 3 value. And so that's why we're using the negative out front. And then the cosine is negative 12 over 13. So it's going to plug in here. And then we are going to simplify algebraically to get our final answer. So we end up with square root of 1 over 26, or after rationalizing, square root of 26 over 26. And it's negative again because of that value out front. And then part B also kind of reviews for us some double angle identity using the tangent then of that same triangle to plug in and find, and again simplify here to find our value of 120 over 119. Okay. Now in quadrant or in the example that they are providing at the bottom of page 312, we have here that the tangent is 3 over 4, so it's positive. So this is going to make it either a quadrant 1 or a quadrant 3 value since tangent's positive. But it says because it's specifically telling us quadrant 3, we know that that's where we're going to want to draw this triangle in. Okay. And since it's opposite over adjacent for our theta, opposite is 3, adjacent is 4, and this is nicely a 3, 4, 5 right triangle. Now, both 3 and 4 are going to be negative because, again, this is quadrant 3, so we move to the left and down. So make sure that you have that adjusted appropriately, and even though it can't be positive tangent. Now, if we are focusing then on finding these values for cosine, half angle, tangent half angle, and sine double angle, we first want to identify the cosine and the sine of our triangle. So cosine is going to be adjacent over hypotenuse, right? And, hypotenuse. And then sine is opposite over hypotenuse. And the nice thing is they told us the tangent already from the beginning, but I'm just going to write it down so we have it handy, 3 over 4. Okay. Now again, because this is a value in the third quadrant, when we look for the cosine of our half angle, we know that this is going to be negative out front because we're in quadrant 3 and cosine is negative in quadrant 3. So 1 plus the cosine of theta divided by 2 means that we're substituting in for cosine of theta the negative 4 over 5 that we found over here. So when we're simplifying even more, we're going to want 1 plus negative 4/5. And just keeping it as a fraction so it's less to right, we have that's 1/5, all divided by 2. So 1/5 divided by 2 is 1/10. So we have negative square root of 1 over 10, which if we break up the party, square root of 1 over 10 is negative 1 over square root 10. And then finally, after rationalizing, is square root of 10 over 10. Now the tangent example, of the half angle requires us to first think about, is tangent going to be positive or negative here? Well, in quadrant 3, our tangent value is positive, right? This is a quadrant 3 value. So that's going to be positive. But we have to be careful because when we divide our tangent value by 2, think about the numbers that are in quadrant 2. So 180 to 270. Any of those values divided by 2 would put you between 90 and 270 divided by 2, which is 135. So no matter what, for the half angle here, we're going to be put into quadrant 2 where the tangent is actually negative. So on this one, you want to be careful because really our half angle is going to end up being a quadrant 2 value since our theta was a quadrant 3 value. And I'm sorry, I misspoke earlier in the video. This is negative because when we cut, again, this angle divided by 2, it was in quadrant 2 where cosine is also negative. So this one was fine for the way we did it. But again, this is going to end up being a quadrant 2 value. So really in quadrant 2, tangent is also negative. And when we look then at 1 minus cosine theta over 1 minus, or excuse me, plus cosine theta, that means it'll be negative 1 minus negative 4/5 and 1 plus negative 4/5. So 1 plus 4/5, because it's minus a negative, gives us a numerator value of 9/5. And then in the denominator, 1 plus negative 4/5 really turns into 1 minus 4/5, which is 1/5. So 9/5 divided by 1/5 can all be in square rooted. These cancel, and we're left with just negative square root 9, which is negative 3. Okay. So again, those 5's canceling out. So again, my apologies about misspeaking about this one. Because our half angle is in quadrant 2, because of the way half of quadrant 3 is, that's why these are going to be negative, because tangent and cosine are both negative in quadrant 2. Okay. All right, finally, our double angle identity, sine of 2 theta. So going back to a previous lesson, because why not? Sine of 2 theta equals 2 cos theta times sine theta. So 2 times negative 4/5 times negative 3/5 is going to be 2 times negative 4 times negative 3, which is going to be positive 24 over 25. Bring it back there. Okay. Now, a couple of last minute questions. In number 10, if we calculate the sine of 105 in 2 different ways using the sum or difference and the half angle, what are we noticing? Well, if we go back to our sum and difference, if we think of sum and difference, we would have sine of 60 times the cosine of 45 plus cos 60 sine 45. So we would have the sine of 60 is square root of 3 over 2 times square root of 2 over 2 plus 1/2 times square root of 2 over 2 for a final answer of square root of 6 plus square root of 2 all over 4, right? If we look at the half angle identities, on the other hand, on this one, we would have sine of 210 divided by 2 would give us, again, the same thing as saying sine of 105. So we always like to think what number divided by 2. And so this will be our theta kind of value that we're plugging in. And 105, the value we're looking for, is in quadrant 2. Sine is positive there. So we would do 1 minus cos of 210 divided by 2. And the cosine of 210 degrees is actually a negative value, right? So we would have 1 minus negative square root of 3 over 2, all divided by 2. And then when we multiply everything by a 2, we end up with 2 plus the square root of 3 all divided by 4, which is just going to be 2 plus the square root of 3 divided by 2. Okay, so 105 is basically found two different ways, right? We have two answers here for that, one using sum and difference, one using half angle. Now, one thing we're going to notice here is that the values are actually equivalent, right? Square root of 6 plus the square root of 2 all divided by 4 is the same decimal approximation than if we do square root of 2 plus square root of 3 divided by 2. We get that same decimal approximation, which shows that they're equivalent, right? But you have to be careful on which way the question's asking you for. If it wants sum and difference, this would be the correct answer. Half angle, this would be the correct answer. Okay, so be aware of which one they're asking for. Now, if they say just find it, either one officially would work. Okay. And one last check your understanding question. If is it possible to find the exact value of a value like, for instance, sine of 65? The answer is no, all right, because we can't add or subtract to any values that we do know to get sine of 65. For instance, like we tried using 45, that would be 45 plus 20. We don't know 20, so we can't use sum and difference. Can't use half angle because we don't know what 130 divided by 2 is, so the half angle is not possible. If we try and do double angle, right, if we try to think about what multiplied by 2 would be 65, we don't know what 32.5 is. That's not an exact value. So you're not going to be able to find every value. That's why it's kind of specific numbers that you see over and over again. But you can find a lot of them, right, that we do know unit circle values for. Okay. Thanks everyone for watching. We're finally done with 23-2. And we'll move on to 23-3 tomorrow.